We will understand the concept of structure and pointer to structure today. For this, two things will be helpful. First is the understanding of class, which we already did before, and understanding of pointer. Okay? So, if you remember, we used to do class like a class student, okay, and then this thing was used, and then we use private in between or public or whatever, and then we put int a, int b, and then functions also used to put. Okay. Same way, if you see, instead of class, structure is used, struct keyword is used, and the student is same as this name. This will be a variable name of that class or structure. Inside, we will not use this private or public keywords because oops concepts are not applicable in structure, but we will put variables. And also, functions are not put. We are using function in class also, right? But functions are not used in structure. That is the difference. But you can put as many as variable you want, and all of them will be like behave like public, but there is no concept of public here. Okay. So just like in class, when you make a student object, you will put student s, right? Student s something, and you can access variable s dot a or s dot name, right? And s dot b. Same way will be applicable here. So when you make a structure, you put structure keyword followed by the student, then the variables which you want to encapsulate inside this structure, and then close the curly braces with this semicolon, like class used to do. Okay? That is a similarity between class and structure, which will help you to understand it, how you write. Now in main, just like I told you, you will write, when you used to write the object of a class, same way you will make an instance of student structure. So we'll put student s. So it will be a instance of student or object of student you can call if you want to compare with class. One more thing will be there. There will be a pointer. So this pointer will point to structure. How? So if you remember, you should write int star p. That will tell to compiler p is pointing to data type of integer. Okay? P is pointing to an integer. That is the meaning of int star p. Here student star p will mean p is pointing to an data type of student. Okay? So first let's remove this, there are a lot of things. Okay? So int star p is equivalent to student star p. There it was pointing to integer data type. It will tell to compiler it is pointing to integer data type. Star p, student star p will tell it is pointing to a variable of student structure or student data type. So this will point to this structure student. But as we know, we used to do, suppose we had a int a, and we used to do p is equal to ampersand a. Okay, int a we used to do. So telling only that p int star p was not enough. We used to do p ampersand a means to which exact variable of integer type it's pointing. So p is pointing to that a variable of integer data type. The same way you have to tell here which exact instance of student it is pointing to. So p is pointing to an instance s of student. So p is equal to ampersand s will make it point to an object s of structure student. Okay. Now, as you remember from class thing, in accessing variable using object is very simple. S dot rol you will put. Okay. So it will access those variable. In class it is different, that it is private public, but here it is simply accessible doing s that object name dot variable name here role inside that structure. So when you put cout, it will give the roll number and print that roll number. And here it is assigned, and it will print that. It will print 2. So till this point is all is clear, I think. It's similar to class thing and some concept of pointer which we taught you. Now let's get to pointer to structure. This pointer to structure has these 2 lines we told you. Okay. Now to access these variables here, to access these variables roll and percent using pointer, this pointer, we have to use this keyword, and it is actually called this keyword, this. So this dash followed by greater than symbol, okay, is used with this pointer here, if you can see. And if in space of dot, if you put pointer name and this keyword, this symbol, you can access these variables. So p and the symbol and roll will get you access to this roll variable, and then you can assign it to any variable, 2, 3, whatever you want. So first print will print simply s dot roll because you assigned it. Now when you do p, this symbol roll, and you are printing it, it will again put print 3. So first print will print 2, second will 3. What about third print? S dot roll you are again doing. Will it print 2? Let's check. So first delete these things and run the program. This is not required actually. This was from previous program. Now you are seeing s dot roll you printed, it is 2. P dot roll is 3, but again s dot roll become 3. Why? It should have been 2 only or not. So this is because s dot roll become 3 now. Let's come back to code and see why. So see, because it is, once again, because it is pointing to same structure, okay, structure with some same variable, int a and roll whatever. So if you see, this s dot roll will also change same variable of same object. Object is same here, s. So s dot roll you can do, it will change exact same variable, and p dot roll if you change, it will also change same variable. So that's why this variable is same here. Okay, doesn't matter you access with s dot roll or p dot roll. Okay, as long as p is pointing to s, p and s are now entangled with each other, means they are coupled. P is pointing to same s integer variable. Okay, so using p, if you change it, I told you that star something there in previous program. So using p, if you change, or using s dot roll you change, the variable is same actually, and it will change. If you would have, so I'll give you one example, one more example. This is happening because p is pointing to s. Okay. In space of that, if you would have one more instance s1, and p is pointing to s1. Okay. Now if you put this 3 statement, third statement will put 2 only. See, the saying the s dot roll now is 2 because now pointer is pointing to different instance of student. So those two variables are not same. Okay. That means, I'll tell you in more detail. So when you make an object of student, two sets of variables will be assigned, roll and percent, and roll, one more roll and one more percent. This will correspond to S, this will correspond to S1. Okay. So when you call it using S dot roll, okay, you make this roll as 2. Okay. When you do S1 dot roll, you will make this roll as 2. But if your pointer is pointing to S, P is equal to ampersand S, then P dot roll and P and this symbol roll, this one, and this P is equal to ampersand if it was S only, suppose. Both will change this variable only. Okay? But now you have done P is equal to ampersand S1. So P dot roll, this symbol roll, because it is now S1, is changing this variable, not this variable. Okay? One more time. Let's delete this. Making two instances of student class, S and S1, will make two different set of variables for roll and percentage. Okay? Roll and percentage. Now, if you do P is equal to ampersand S, suppose this is a statement here, not S1 right now. And then you apply statement S dot roll. It will access this variable. And you still have P is equal to ampersand S. So P dot roll, this symbol roll, roll symbol will again access this same variable. If P is equal to ampersand S you have put using first S object. Okay? So that's why when you are putting S dot roll here in this one and then doing P dot roll 3, then again you are accessing S dot roll here. It was giving 3. But now you have given P equal to S1. So first time you put S dot roll, it is accessing this S dot roll. Now you do P roll and now P is equal to ampersand S1. So this this symbol roll, this symbol roll will access this variable. So this will be different set of variable, okay? So that's why when you do S dot roll with P equal to ampersand S1, it is printing 2 because it is the earlier variable. But P dot roll is printing 3 because it has changed this variable. Understood? I think you understood. So let's stop this video.